Okay, so another one. Determine the type of discontinuity of g of x is equal to 1 over x at x is equal to 0. Now, we cannot solve it algebraically, so we should create a table of value to identify the the limit of the function. So x is equal to 0 while the g of x is equal to 1 over x. At g of 0, it is undefined, 1 over 0. So the g of c is undefined. Now, if we create the table of value, we can see that as x approaches to the value of 0, the value of f of x approaches to positive infinity. At the right side table, as the value of x approaches to 0, the value of f of x approaches to positive infinity. So the left side limit is not equal to the right side limit. So the limit of the function is d and e. And since we are talking about infinities here on its in its limit, therefore this type of discontinuity is what we call infinite essential discontinuity. We can verify that here on the graph of the function. So in the left side, it is approaching to negative infinity as it approaches the value of 0, while on the other side, as x approaches to the value of 0, the f of x approaches to positive infinity. So infinite essential discontinuity. Okay, so here's the summary. Take this guide to determine the type of discontinuity. First question, does the limit exist at x is equal to c? If the answer is yes, another question to be asked, is limit of f of x as x approaches c is equal to the f of c? If your answer is still yes, then our function is continuous at c. But if your answer is no, it means that your function has irremovable discontinuity. So it means this is discontinuous because the value of the limit is not equal to the f of c, but the limit exists. Okay, back to the first question. Does the limit um, of the function as x approaches c exist? If your answer this time is no, then another question to be asked. Do the one-sided limit exist but are unequal? If your answer is no, then it means that your function has an infinite essential discontinuity. But if your answer is yes, it means that your function has a jump essential discontinuity. So it means here in jump essential discontinuity that your limit does not exist, but they have an individual value of the limits in the left side and on the right side. Note that here the function must be defined on an interval containing the value of c, except possibly at c itself. So thank you for listening, class. I hope you have learned something today. God bless, and you can answer your activity number 3 on your Google Classroom account. God bless you.